I've got my ammonia plant, my chemical factory, and my plant produces 6.5 times 10 to the 6 grams of ammonia in a year. Question is, what masses of nitrogen and hydrogen did I start with to be able to make this much ammonia, or how much would I need to buy for next year if I want to make that much ammonia? Here's our reaction down here that shows us our mole ratios of 1 mole of nitrogen for every 3 moles of hydrogen to form 2 moles of ammonia. So same question is at the top of the screen now, just a little bit smaller so I have more room to write. Where do we start here? So you're given this piece of information, and that is definitely your starting point. But in order to use that roadmap, I need to know this value in moles rather than in grams. So my first step is whatever is given to you, whatever form it's in, you need to figure out, you need to convert it to moles. And what do we use to convert between mass and moles? We use molar mass. And if we look it up, maybe I'll just make a little list over here of my molar masses. If we look up the mass of nitrogen and add it to the mass of 3 times hydrogen, the molar mass, that gives us a mass of 17.31 grams per mole. And while I'm talking about molar masses, we're also going to end up needing the molar masses for the diatomic nitrogen molecule, and that molar mass is 28.014, doubling the molar mass of just nitrogen by itself. And we'll also need hydrogen, and that molar mass is 2.016 grams for every 1 mole. So we'll need those numbers for sure. So my given is grams of ammonia. I want to convert that into moles, so I'm going to use the equivalency that 1 mole of ammonia has a mass of 17.31 grams. And if I calculate that out, I should get 3.82 times 10 to the 5th moles. Does it make sense to have a pretty big number? Yeah, it does, because I'm talking about the amount of the mass of ammonia produced by a factory in a year. So this is a pretty big number. So that's my first step on the roadmap. My second step is to use the mole ratio. So 3.82 times 10 to the 5th moles of ammonia. And it starts to become really important in stoichiometry to not just label this with the abbreviation mole, but also moles of what? Moles of ammonia. Because the next step would be to calculate how many moles of, let's start out with nitrogen, how many moles of nitrogen we're going to get. So I want moles of ammonia to cancel out, and I want to get moles of nitrogen. And what is that ratio? Where do we find that? We find it in the balanced chemical equation. For every 2 moles of ammonia, that's my product down here, we require 1 mole of nitrogen. Basically I'm just in this equation, in this reaction, I have half as much nitrogen as I do ammonia. And so this gives us 1.91 times 10 to the 5th moles of nitrogen. So that's not exactly what the question asked for, though. The question asked for masses of nitrogen and hydrogen. So the next step would be to take that molar amount of nitrogen and convert that to a mass. Again, just like in that first conversion here, I went from 1 mole, or I went from grams to moles. I'm here going from moles to grams. So I want moles on the bottom to cancel out. And then every 1 mole of nitrogen has a mass of 28.014 grams. A little hard to read there, but that says 0.014. And that calculation gives us a mass of, this now answers the first part of the question. What mass of nitrogen, N2, is required to make this much ammonia? Now, let's start with a blank slate to answer the second part of this question. What mass of hydrogen is required to make this much ammonia? And I'm going to show you just kind of how to do it in one step. On the previous slide, we calculated that 6.5 times 10 to the 6 grams of ammonia is equivalent to 3.52 times 10 to the 5th moles of ammonia. And yeah, I need to use this balanced chemical equation to first calculate or convert this number into moles of hydrogen. So yeah, a mole ratio is something that's going to compare moles of ammonia to, in this case, moles of hydrogen, because that's the part of the question we haven't answered yet. And yeah, looking up to this formula, or this equation, every 2 moles of ammonia require 3 moles of hydrogen. Now I could write an equal sign and calculate the moles of hydrogen, but I'm going to show you how to do it, calculate the mass in kind of one line or one step. So I've shown that mole ratio as a conversion factor, and then the next thing I'm going to do is convert that molar amount of hydrogen to mass right here in the same calculation. So yeah, that mass of, we want moles of hydrogen to cancel out, and we want to get to grams of hydrogen. The molar mass of hydrogen is 2 times the atomic mass of hydrogen, because there's 2 atoms in each of these molecules, and that ends up being 2.02 grams for every 1 mole. So yeah, now our moles of ammonia cancel, our moles of hydrogen cancel, and we're left with grams of hydrogen. And that calculation ends up coming out to 1.15 times 10 to the 6th grams of hydrogen. So that's a quick rundown on an example problem using mole ratios and using the molar conversions that we've been working on in class. So I hope you find it helpful.